issues. So as I've said, what happens is we call, let me just go back to it. So we create a class. So with the class keyword, and then the class should have start with a capital letter. Then now you bring in the constructor function, which is going to run once when you call an instance on the class. And when it runs, it initializes the properties on the instance you're creating. So the instances, the properties are going to be whatever arguments you're passing into the function when you call it. So now when we call this, I said, now you pass in the values in the order in which they appear in your constructor. So if you swap them, as I've done it here, so the real values to the arguments, Python, then IDA, here I have name and course. So if I swap them this way, I'm going to get the output, hello, my name is Python, I am doing IDA. So they must come in that given order, no swapping. So if you swap them, then you get them the way I have just demonstrated. So the correct way, the name should be the first one. Then the course comes next. So when you, before you even pass in whatever arguments, when you hover over this, you can even just see the constructor tells you it requires a name first and then the course. So that is basically how you pass in the values to the keys that you have initialized, or the properties you've initialized in your constructor function. Right, I think that makes it clear for us to understand. Then we, now when you're passing in to get the real values, so rather when you are initializing to get the values from the object class you have created, you reference with this keyword. This keyword just refers to the same class that you have constructed. So when I say this dot name, it's going to pick the student's name. So the student object that is going to be created and the name that is going to be passed in. So that is going to be the object. So student one is now this student we have created. So student one's name is going to be this name. Student one's course is going to be that course. Any object that is created is going to be that object. I don't know what's happening again today. Let me adjust my router again and see. I don't know how the audio is coming now. I hope I'm audible now. Confirm that. Hope my voice is not breaking. Can you hear me clearly now? Okay, I think I got it from 2 people. Hoping it doesn't act up again. Right, so I was just insisting on the order in which the parameters or the properties you're passing in come whenever you are calling that instance. And I said, when you are now calling the instance, we call the student. So this, any instance, so these are just instances that are now being created. So when you create an instance, you now pass in the real property. So basically, it's not like it is going to be student 1, student 2, but you can give them even real values, or the variables can really be relatable to whatever that is. Maybe I want to have a student called Kyle. So when I bring in Kyle, I'll say now Kyle is going to be equal to the new, I call the instance on the object, and now pass in, let's say the name is now that Kyle, and Kyle is doing DevOps engineering. So when I call that, I'm going to have that student created. So when I now pass in the method on that student, so if I do my student Kyle with the method greet on him, then it is going to run and give me the student's name is Kyle, doing DevOps engineering. So hi, or hello, my name is Kyle. I'm doing DevOps engineering. So hello, my name is Kyle. I am doing DevOps engineering. So that was on creating instances. So that is basically just creating the instances. Now, when it comes to inheritance, we say now a class. Okay, let me talk about abstraction first. Abstraction was where we hide some, or rather make some properties only accessible in the class itself. So when I access the balance inside the class here, I get to see the balance. But if I try to access it elsewhere, outside, that is outside the class, I get an error. I can't do that. And we even went in to try and, let's say we are trying to hack into the bank account and insert some weird values. So someone comes in and wants to just update their account balance to 50 million. So when you try that, you get an error. So you don't get to update that in your account. So we run into an error, a syntax error. Private field must be declared in an enclosing class. The enclosing class, which is the class which has instantiated that given property. So you cannot access it outside. So when we try to change the balance. So here in the try block, we were just trying to now update the variable for the balance. So say my balance, account balance is 50 million, then I get that given error. But if you create another variable, it's just going to be volatile, where you now say your account balance is 50,000. This brings back when you log, you get that not 50,000, the 50 million. When you log this, is it 50 or 5 million? They're about. So when you log, you get that balance. But now, when you check the balance in the account remains what balance that is privatized. You don't get any addition as from what you had as a variable to add that. So that is what we got from that. Then that was abstraction, just hiding some information to make it inaccessible. Then inheritance is where you have a class that lends, let me just use that term, lends its properties to another subclass, which is a child class. So I create a class for a user, and then the user has its properties, which is the username and email. Then now the method login, which is going to be like universal, all the instances that are going to inherit from that, not instances, subclasses that are going to inherit from the user class are going to have that method. And then now we have a class for an admin. Now, inheriting for inheritance, we use the extends keyword. So class admin extends user. So extends user is the class that we have up here. So extend or take all the properties that the user has, properties including methods. So take all of them. So now it will, now you still initialize the properties, but now you can see where the difference comes. On the child object or the child class, we have additional parameters. So like this is an admin level parameter we've added. So when we now want to get the properties of the parent, so we said we use the super method. So using super, we now pass in the username and the email. We don't initialize them the way they have been initialized here, this dot username. So we just call super and pass in username and email, and it will now instantiate everything that comes from the constructor up here. And now we now bring in the instantiation of the property for the admin level, or the additional properties or parameters we are adding on this. And this one has its own methods, unique methods just for it. Delete user cannot be used by any other class that is created. It's only unique to the admin. So it's only admin who can delete users. But a regular user, so any user created using the user object can log in, because that is the method on the user. So just a user will log in, but cannot delete user. So when we tried to delete the user using the, so that is the regular user we have created here, and we want that user to delete a user. It cannot happen when you try to run that? Now we get an error, type error, regular user dot delete user is not a function. Why? It's not a function because when you go to a regular user, the function, so this one is getting it or inheriting from, or is being instantiated from the user class. So when you go to the user class, you don't have a delete user as a function there. So that is why you get, you cannot delete a user when you are not an admin. So we are now seeing where and how the inheritance works, where and how abstraction works. So to that point, we go into look at the next thing, which is I'll come to, let me start with, we've looked at encapsulation. We now look at abstraction. So take it this way, like now when you go to, or rather when you are driving or when you have a car, there are internal mechanisms that you don't really care about, or you don't really know how these things do work. So the only thing you see is like when you look at the speedometer showing the speed of that vehicle, you don't know how the calculations are done internally, how the mechanics of the vehicle moving works, but yours is just to see the speed increasing or reducing. Yours is just to see how much fuel that vehicle has. But how that is calculated inside, or how everything is done, is not your worry. So the complex things are hidden from you. You are only given whatever stuff is consumable to you, whatever you can just see. So that is basically what is the underlying factor of abstraction. So with that, let's go into code and see, when we talk of abstraction, what is sorry, what is that all about? So think of it this way. Let me put it like go into detail of just trying to bring that. So think of there different types of coffee, but there is only one coffee machine. So the coffee machine is one, but there are different types of coffee. We have cappuccino, we have, I don't know which one and which one. So there are different types of coffee that we can make. Now, when we make that coffee, it's not just about cappuccino, but there are steps into making that coffee. So all the underlying methods, or rather, I may talk of a recipe. So a recipe for making coffee has steps. So all those steps you don't know about, but yours is just to get coffee ready. So when you get into a restaurant, bring me cappuccino, and then a cup of or a mug of cappuccino is brought to your table. But how it was made, you just saw a button click on the coffee maker machine, and now you get the coffee. Everything how it's none of your business. So that is basically what abstraction is all about. So let's create that class. Let me just go with that coffee machine. So let me just call it coffee machine. So we create a coffee machine object and initialize the properties. So using the constructor method, we come in and initialize. We just want to get the coffee type. So the type of coffee that we are making. So that is basically what I'll just have here. And now say this dot this dot coffee type is going to be that coffee type we are going to make. So that is now the blueprint of our coffee making machine. So we are going to make any coffee from this given machine. So we pass in the method make coffee. So let me just pass in make coffee as a method coffee. So this is going to be a method that is going to be used to make the coffee we are going to be making. So this coffee maker, we have said we are hiding complex things from being shown to the user. And abstraction is basically also uses the hash. So I know we'll get a little bit of confusion between encapsulation and abstraction. They are pretty much similar, but now the difference is, like you saw the method when we come to encapsulation, the method is tied, or rather, the property is declared before. So here you declare the property, and then you can now tie that property to a variable. But now when we come to this one, abstraction, so you just bring in the properties in here. So I want to hide okay, let me find the correct words to just make us understand this clearly. Basically, I want to hide, as I said, I don't want to, someone doesn't want to know how the coffee is being made. But when I just call the function make coffee, I get coffee done. But how this is being done, I don't really want to know how it is done. So I just want to have the coffee done. So I'll just hide every complex mechanism. So using the hash, that is how you hide the complex activities that go on behind the scenes. And now here, I'm going to hide the functions or methods of making coffee. So it's not a variable as it was in encapsulation. So here, let me say the first step is boil water. So I'll just say boil water. That is the first method I'll have here. And maybe we can just log that before and say we are making the coffee. So maybe let's say starting to make your coffee type. So we can just pass in your coffee type here. To make this, that's going to be this dot coffee type. So starting to make, if it is cappuccino, so it's to say starting to make cappuccino. So now boiling water and all the rest, we will not even be privy to. We don't know how it is being done, but what we'll just see is the coffee has been made. So boiling water, then grinding the beans. So I'll just say grinding beans. So grinding the beans and then now brewing the coffee. So I'll also say this dot using a hashtag, say brew. So I'll just say brew the coffee. So just call brew on it. So once these are done, I can now give you the coffee. So here we'll just say also console.log. So let's just log this and have it done here. So console.log. Then you can say your coffee type is ready. So your this dot coffee type. Bring this back here. I hope I'm not breaking now. We are okay with the voice is ready. So I can bring that in here. So say your coffee is ready. So I can just have it that way. So you already have your coffee. So now these methods, I'll now define these methods just internally. As we said, we are doing it in the class. So define the methods. I'll have my method. We had the first one is boil water. So boil water. So with my boil water method, I want to just say console.log let's say heating water at maybe how many degrees Celsius? Maybe 95. 95 degrees. So that is the first step. Then the next one, we want to grind the beans. So I'll say hash grind beans. And basically, I'm just logging so that we grind, not grind. So console.log here. So in our log statement here, we are going to just say, what are we doing? So grinding the beans, into a fine powder. So we are making a very fine powder of the beans. And lastly, we want to now brew the coffee. So with all these methods and console logs, you're not going to get to see, like when you instantiate that or create a coffee type, we are not going to see all these methods or like now, like when you run that, you see starting to make coffee, like whatever we'll see is just starting to make coffee and then your coffee is ready. But heating water, grinding beans, brewing the coffee, we will not see all these methods. So, sorry, console log. So let's finish it up and see what we have. Sorry, console.log. Let's say passing hot water through the ground powder under high pressure. Under high pressure. So you can have it that way. So these methods are just tied to the machine, how the machine works behind the scenes. You don't want to know much about that. So when we now create an instance, so create coffee type. So we are going to create a coffee type here, and let's say so let's say I'm taking my machine to make this coffee. So let me just declare a variable call it my machine. So I'm using the machine to make cappuccino. So I'll say new coffee machine. And now this one is going to make what? Cappuccino. Is it usually cappuccino is usually double C, not CH. So when I call it here, then now bring in the method make coffee. So when I now run that and now say my machine, so our machine dot the method make coffee on it. So when we make coffee using this machine, so what are we going to get? We're only going to get that the machine is making our coffee. Let me comment out this other code going upwards, what we had done yesterday. So we don't have much to log, just log whatever we have here. Only have this. So now when I run this, I get what is let me see what's inside there. So, okay. Let me run it again. Grind beans. I'm seeing a hand before I clear that out. Ian?
Okay, I think the problem with your code, when you wrote there make coffee this dot hash wrote grinding beans, but when you are calling it out you wrote grind beans alone. I think they don't match.
Oh, thank you. Yeah, that is correct. Grinding beans, not grind beans. Thank you. That is it. Yeah. Now, when we run this, we now the output should have been just the all right, yeah. The output, so we are just getting the console logs coming. But now, when we try to to see how the beans are ground, so like internally, it grinds beans, boils water, and brews the coffee. So when I try to access, or rather, when I say my machine, let me do that here. So if we do my machine dot now hash grinding beans. When I try to get to see how the beans are ground, I'll get the error, that property. So you see, those are hidden. So private field must be declared in an enclosing class. So it brings out the output just as what we saw on the encapsulation. So you cannot know how the beans are ground, but you can only get to see the coffee is made. So all the internal mechanisms are just hidden. So all this, whatever is happening in here, so this was just a console log to output whatever we are doing in the functions. But whatever happens in the functions here is only specific to the coffee machine. So it's only the coffee machine that knows how to make the coffee and how it boils the water, how it grinds the beans, and how it brews the coffee, and now gives you the output. But you cannot access those methods yourself. So that is basically what is on abstraction. Just having private fields private to the class object. And that's why yesterday I said abstraction and encapsulation are pretty much related. But now the difference we are getting is the methods. Encapsulation was the properties, hiding the properties so that you cannot manipulate the values and change anything. But now when it comes to abstraction, hiding complex methods or complex functions from the user. So just giving the user whatever methods they can access. So we can only access the method make coffee. So you can see, if I add a hash on make coffee, I make it private. So the moment you add a hash, so let me just do it this way. So if I do make coffee, I hash it that way. So when I run this, so I have abstracted that from the user. So you can see make coffee is not a function. So when I even add the hash on it, so when I add a hash here, so my machine.hash make coffee and run that, I get a private field. So whenever you want to privatize functions, you'll use abstraction. So I'll just abstract that from the user, and they cannot access that. Breaking again. I don't know what's happened with my network these days. Still breaking? Aisha, you can't hear? Okay, so I don't know what's happening with the network, but I hope it doesn't go on this way. Yes, Dennis?
The shortcut that you told us yesterday to comment out a whole, like, so many lines of code.
Okay, it's basically just highlighting that code. So you just highlight the section you want to comment out. So once you've highlighted, then you do control and /.
Okay. Thank you.
All right. I think there is another. All right. So let's look at it now at an angle that we can now see the difference. So let me just comment this and comment this. So on encapsulation, so encapsulation, basically what we are doing on encapsulation is hiding internal state. So state here referring to data. So hiding internal data or protecting it from corruption, protecting it from any manipulation. So like making it read only. So you can make it read only. When you want to have a field as a read only field, so you privatize that field. So you can only read from it, but you cannot write to that given property. Dennis? See your hand again?
I'm saying,
Yes.
I have a problem with my code and I'm trying to fix it and I don't know how to do it because I think it's correct,
Okay,
but
share your
there's an
screen
error.
before we finish up explaining this.
So I think the error starts here, but
Let me see. Make coffee. Then you have starting coffee. Dot. Okay. Yeah, the error is because now your coffee machine class is already closed. All these methods are just inside. They are closed inside there. They are class level. So from line 158 to line 149 should be inside your class.
I cannot hear you.
I don't know if you make sense of that. Dennis? Dennis, I'm not getting response from you. Dennis?
I can't hear you clearly. You're buffering.
Come again? I don't know if it is my network. My network. I don't know if it's okay there. I'm trying to just move my router around. Am I audible?
Yeah, I can hear. Yeah.
So I was saying from line 141 to line 158, these are class, we said from abstraction, you are putting your methods are inside the class, but you as you have passed your methods outside the class. Your class is already closed. You now understand? Grinding beans, 153 should be grinding beans or change grind. Yeah, 153 should be ing, grinding, the method that we have up there. It's okay, down there, it's already running. Scroll down, so you'll start to make coffee. It's okay.
Okay, thank you.
All right. Okay, so let me make it clear to Ida and all of us. Now, here I was saying this balance is a read-only property. You cannot access it any other way. Like you want to change anything on it, you cannot do anything on that. So I can only read from it. That is why we are saying when we have our method check balance. So the check balance method can only read the balance that we have because it's protected. But if we try to do something like attempting to change that variable value, we get an error. It is a private field, so we cannot manipulate that. So that is encapsulation. So encapsulation goes with the variables or the properties themselves, data fields that we need to work with. But when we come to encapsulation, is now the methods, hiding complex methods or functions from the user. So internally, those functions are running and doing something, but the user only sees whatever you want them to see. So when we come to abstraction, so a method like boil water, so that method, how it is working, it is internally in the class. So it's only the class that knows how the water is being boiled, how the coffee beans are being ground, how the brewing goes on. So with the example I showed of, or I started with of a vehicle. So how the fuel is being injected in the engine for the engine to run, we don't know. Ours is just have the vehicle move. So I can only have like the function ignite the vehicle. So when I just take my key into the ignition and then turn it on, the vehicle starts moving. So how does it work? How the engine starts, how the combustion goes on, I don't know. But those things are happening in the vehicle. I don't know if that now makes a little bit of sense to you, Ida. You now get it? Yeah, so the key thing is just abstraction goes with methods or functions. Encapsulation goes with data fields or the data variables or the properties. So that is the key difference between the two. Okay, so let me just give you a few instructions for you to try out abstraction. So I want you to make a smart device class. So a smart device class that is going to handle different like that has different methods in it. So when you turn it like you're going to create 3 devices from that abstract class. So we are going to have a smart light. So like I talked of the coffee machine. So let me just bring it. Like here, I created a machine that makes cappuccino. Another one that you can create another one that makes a different type of coffee. So let me bring that here first of all, and let me say const. Let me call it what? Espresso. That is another coffee type. So if I bring in espresso, so that is going to be new coffee machine, and that is going to make for me espresso. So when I call this one, so when I call espresso dot espresso dot make coffee. So if I call this one, it's going to make coffee, but it's going to make coffee type. Which coffee type? Espresso. So different, you can have different, which one? Oh, I still have delete user uncommented here. So I now make espresso, and I get your espresso is ready. So starting to make espresso, heating water, grinding beans, passing hot water, your espresso is ready. So we can create different types of coffee just using the same machine. So using the same smart device, so these are the instructions. So using the same smart device, you are going to have a smart light. This one needs to manage brightness between 0 and 100 degrees. So turning it on sets the brightness to 100. Turning it off sets the brightness to 0. Then another smart device, a smart thermostat that is going to set temperatures, room temperatures for your house. So turning it on sets the temperature to, let's say, 22 degrees, a very comfortable temperature there. And then you have a smart camera. So that is basically like a CCTV you also have in your smart device, just doing how do we call it? This term is running away. Okay, so integrating these systems into one device. So you have one device, like one system on your mobile phone that powers on the lights, turns on the thermostat, and powers your smart camera. So when you turn on the camera, it starts recording. When you turn it off, it stops the recording. So yeah, just those 3. Create a smart device class that powers on smart light, smart thermostat, and smart camera. I hope it is clear. Let me just have this typed and shared on the chat so that we can do exactly what I'm saying. I've shared on the chat that makes it clear for us to understand. I give you 5 minutes to try and do that. All right, I believe someone is ready to share what they've done. Who's ready to go? Someone ready? Anyone? The problem is you people keep quiet. You can't even know if you're on it or what. All right, maybe give you 5 more minutes. ready to showcase what they've done? Because we are silent, I'll choose out. Jason, maybe you can have yours. Let's see what you've done. Jason, I don't know if you heard me. Jason, not getting any response.
Can you hear me?
Yes.
I don't know if my net is making.
You're breaking too. I don't know if it is my network, but like you are muted, but I can't hear anything from you.
Can you hear me? I don't know. Am I audible?
Yes, I can hear. I can now hear you. Okay, just saying one word, then you go silent.
Let me just refresh my page. I don't know. My network is having problems.
I can hear you now. Are you sharing? Because I'm not seeing anything from you. Jason. I don't know, there are issues with network or what's happening. Okay. As it prepares, maybe who will share next? Aisha, mind sharing what you've done? As I said, not that you must have something perfect, but just having something guiding you along the way, seeing how much you made understanding of what we're doing. Share as we wait for Jason.
Okay, I've not done much, but let me share.
Okay.
So I created a class called Smart Device. Then I created a constructor which would automatically run when a new object is whenever a new object is created. Then I passed in the name parameter as a parameter. Then this name is equal to name is supposed to store the value which is passed on to the constructor. This is on false. This means that the device state will be, by default, will be false. Then I created two methods, turn on and turn off. So turn on, this is on true. We'll set the device state to on. Then this is on, false. We'll set the device state to off. Then I created a child class, Smart Light. Then I use extends so that it will inherit everything from the smart device automatically. This means that it will inherit this name is equals to name, this is on, and this turn on and turn off. Then I created a constructor for the smart light and super name. This is supposed to, it calls the parent class constructor. Then this brightness is equal to 0. I was adding a property only for lights, whereby the brightness starts at 0. Yeah, so that's what I've done so far. Or this super name was supposed to ensure that there is no, there is no error, because without it there will be an error. JavaScript would throw an error.
Yeah, because you'll not have initialized those given properties. Okay, you're just on the right track, but basically now the abstraction layer of it is what I wanted to see. Okay, Jason, I think your network is now okay. You can share what you have before we take a break and come back and continue. Jason?
I've not done that much.
It's all about just, I want to see all this time, what have we been doing? So you just share what you've done so far.
Okay, this is where now I am. Basically, I was just doing the same thing, but I was just first looking at it so that I can understand how I was supposed to do it. Because now the whole concept about the abstraction is a bit quite confusing.
Okay. Let's just take a break. Circle back at give you the 24 remaining minutes. Circle back at 11:30, and then Ian, before we go for break, I'm seeing a hand.
Okay, Zasin, can I share mine?
Yeah.
Can I share mine? I saw it was. Okay.
Yes.
I saw it was a little bit different from the one Aisha had presented us. So this is how mine looks. The class, our smart device, the constructor just put in light, and then this dot light is equals to light. And then I put in a method that is turn on. This dot light is 100%, console.log, the light is on.
You are really breaking. I don't know if it is my network or what's happening.
Okay, let me try and reshare.
Can you hear me clearly?
Am I good now, or I'm still breaking? Am I audible now?
Confirm if you can hear Ian on your side, because I'm not getting him.
Am I audible? Because I can't hear.
Can anyone hear Ian? Confirm if you can hear him. Then I see maybe it's my network. Can you hear Ian, you guys? I don't know why I can't hear him. And you can hear me clearly?
You can.
Also,
yes, I can hear you. I can hear you now.
Okay. You are now clear. So you can go at it. Let's see what you have.
Okay, I was saying I just used this one. I don't know if it's correct, but it was giving me a good output. I used the class smart is smart device. The constructor just put in light simply to adjust the brightness. Then turn on, I automatically put it, the light is on to 100%. When you run it, the light is on, brightness is at light mean it will be giving the light is 100. Then turn off, I put it to 0, can just be the same as true or false. When you run it, it will say the light is off, brightness is 0. And then for the smart device, okay, and then I just light.turn on, call it down here. The smart camera, I used on, because it was instruction use recording, the constructor to be recording, this is recording. When the camera is on, it should be recording started. And then when the camera is off, recording has stopped, we call it out. And then this is what the output was. I don't know if it is correct.
You have done it, yes, but now where is the abstraction? So abstraction is basically hiding these methods. So you haven't hidden the methods. They are just publicly available. Like I can call the method anywhere. If I call where's that? I'm only seeing camera. You've only constructed a camera, like where the other devices. So I'm only seeing like the camera. Now, if I call like these methods should be abstracted, like if I try to access a method turn off, it should only be tied on a device, but how it is turning off, I shouldn't access that. So method turn on, turn off should be abstract or abstracted methods. But now the global methods like camera on and camera off, those are specific to that smart camera. But here, like whatever you've done is creating different classes.
Audible.
Just created different classes. I think after the break, I'll do a dive in and just maybe show you what we were to do. So we can take the break, then we circle back after the break. I hope we are back. Just to confirm from you guys. If you can hear me. Can you confirm? Got it from Derek. All right, so seemingly from the implementation I've seen from you guys, let me just dive in and give you like whatever expectation I wanted or I would love to have seen from you guys. The layers I saw missing on whatever you people presented were like these abstracted methods that a user doesn't care about. So doesn't really want to know how things are working behind the scenes. All I want to have is just like a single method that takes in all those other methods and now returns to the user. So what I'll do is let's just go to it and create our smart device. So we say the base class is just our smart device. So I'll have my smart device. So my smart device, what have I done here? So my smart device takes in, we can hide complex. I saw you bringing in brightness, temperature. So those can be internal states. So we can bring in encapsulation here. So like it doesn't work in isolation. So you can bring in encapsulation and abstraction work together. You can do all of them. I saw that was Aisha, I think bringing in that is inheritance. So you can have all of them together. So I'll bring in my brightness. So I'll just say brightness and set my brightness here. So we said initially, let it be at 0 so that now when we power on, it sets it to 100. So now have that, then also have the temperature at 0. So because the temperature was also to be set at 22 degrees around there. So I'll say my temperature is just 0.0. So I can have it at 0.0 degrees. And then the recording of the camera should only also power on when I set it. So I can have a Boolean here. So let's have a Boolean of is recording. So initially, it's not recording, it's false. So once we have this, then we can now create our constructor. So our constructor takes in the name of the device and the device type. So I'll take in the device type. So that should take in those two. And then I now come in with the initialization. So this dot name is going to be the name of the device and then bring in the device type. So this dot device type is going to be equal to that device type. So basically what I said, you are going to have how many devices? So you're going to have a light device, a camera, and a thermostat. So those three are going to be the ones taking in the device type. Then now you can now bring in the method that is going to be used by all the devices. So the only method a user will need is just the method to power on or to activate the given device. So let me just call it activate. So the activate method. So this is the method that is going to be accessible by all. So in this, then let me just put it almost the same as what we had. I wanted just you to borrow from what we had done and see how you can now improve that or bring that to this use case. So you can say, let's have starting activation of starting, not stuttering, should be starting. So starting activation of the given device. So I'll just do $, curly braces, this dot. Now the name of the device. So we start the device, and then now we can go in and now bring in the abstraction, hide the complex methods from the user. So that those are going to be just called inside this activate device. And I'm just going to use an if statement to just check the device types. So I can say if the device type is, so if this device type, so if the device type is which one? So if the device type is a light device, so maybe it's your light bulb, sorry. So if it's a light bulb, then I'll power that light bulb on. So abstract that, how it powers on. I'll just say, let me bring this first. So this dot hash power on. So I'll just say power on. So I power on, and then now set the brightness. So we have brightness, which was 0. Now I set the brightness to 100. So this dot now, let me say set brightness. So I'll bring in a function or method that is going to set the brightness. So I'll just say set brightness. So set the brightness. So that is to do with now our light bulb. Then if not that, then that is else. So else if our device, because there are 3, I'll use the else if and then else last. So else if the device is this dot device type. So if the device type is strictly which device? A thermostat. So that was the next one, a thermostat. Do you have a thermostat. I think that's the correct spelling. So if it is thermostat, then what do you want to do? So this, so bring in the method on this. So this dot, how do we want to set the thermostat? Maybe I want to read the sensor for it to just set the temperature for us. So read the sensor, and then now I can also bring in can do this method here again. So hash now set the comfortable temperature for us. So set temperature. So I'll set the temperature here. And lastly, now go to the last device type. So I'll say else if the device type is now if the device type is now that is the camera, so if the device type is camera, then what do we want to do with the camera? So now this dot set the method that we want to have on the camera. Maybe let me call it start lens. So start lens, just adjust the length for us, and then now get the recording. So we can say this dot hash let me say start recording. So we now start recording. So these are now methods that the user doesn't want to know about. So basically the console logs were basically just to print out what is happening. So those are going to come in the functions we are going to now have. So once I have this one, so let me just have one log. So after this, then we can just do a console log. Console.log, and have a message here. So your device, so we can say this dot name. So this dot name is what do we put here? Fully operational. So it is now operating. So it's fully operational. So once all this, whichever function, whichever device you are picking, it will go into the if statement for it and pick whatever it has to have it run. So then now we can now come and define our methods here. So the first method was power on. So I'll come in and now bring my power on method here. So my power on method just have a console log. So console.log, and powering the LED. Maybe it's an LED device. Then it powers on and then sets brightness. So hash set brightness. So let me just even be picking them here quickly. So if I take it that way, so bring it here. So set brightness. We're just going to console log and say setting brightness that was to 100% to 100%. So I can have it just that way. Then go to the next one. So it was just to be, I know it's a bit complex, but this is how we were to just have it. So set, now read sensor. And console.log and bring in the message, maybe reading the room temperature. Let me say ambient room temperature. So this is what we have on that. Then we can go to the next one. So once it reads the temperature, it now sets the temperature. So reads the temperature of the house and adjusts the thermostat to the desired temperature. So here also console.log message is now so setting the temperature, because the temperature has 0 degrees. We can bring in the temperature and yeah, even the brightness. I didn't set the brightness, so I have brightness at 0. So I need to set the brightness here. Is that here? So I need to set the brightness to 100. So I'll say this dot, that was brightness. Now set that brightness to 100. So say this one is 100. So same happens to this one. Before we log that, so we say this dot now read no temperature. This dot temperature, our temperature that was 0, now set the temperature to that temperature you want to have. We said we want to have it at about 22 degrees, so set it at that. Then we can now say what message do we pass in here? So let me say engaging high voltage alternating current, so HVAC. So high voltage alternating current compressor to target just what we want to have, 22.0 degrees. So just that. Then what next do we have? Set temperature, we've got that. Then go to our camera. So go to the next one. This one now here. Start lens. So console.log This one will just say maybe powering on the maybe optical sensors for night vision. Optical sensors for night vision. So once we set them on, then we can now call the last one, start recording. So there was start recording. We had the recording as false. So we want to set it as to true. So now, once we set that, we say this dot is recording. Now we bring this to true. So we now start recording. And then now we can log that. So we can say console.log let me just say maybe encrypting the video video streaming. So encrypting video streaming to secure cloud storage. So we have our methods done. So we have everything now done correctly here. So we can now create the different devices. So that is basically what we want to do. So I'll declare a variable that stores my light bulb. So let me call it const, not console. Const my light bulb, or let me call it my smart bulb. My smart bulb. So my smart bulb is going to be equal to new smart device. So the new smart device is going to now take in, as we declared it, we want to have two things come in. So we have the name and the device type. So the name may be, say maybe this one is my living room bulb. So living room bulb. And then it takes in the device type. So we were using the strict operators are checking for this type of device. So if it is light, so I now bring in the device type to be a light device. Then let me just duplicate this 3 times, change this one instead of my smart bulb. Let me just have it as my thermostat. My thermostat. So that is going to be maybe my main thermostat. And this one here is going to be thermostat. And this last one is going to be my camera. Maybe the front door camera. So here we get our camera. So the device is camera. So now we'll just call our method. So the single basic method that activates our device. So we'll just call our activate method on our devices. So if I call my smart bulb dot activate, then call my my thermostat with the same method. So you can see it's just that same method called on all the devices that we have, and we are going to have it now do what we have. So my camera, where's my camera? Lost. Oh, this one should have been my camera. So I call my camera dot activate. So if I do this, now we should see exactly this doing as expected. So when I come to it now here, let's see, starting activation of the living room bulb, powering the LED, setting brightness to 100%. Your living room bulb is fully operational. Starting activation of the main thermostat, reading the ambient room temperature, engaging HVAC compressor to target 22, then your main thermostat is fully operational. Then just like that. These are the things you've seen even on like those small smart devices you have. These are basically what runs behind the scenes. There are functions doing some things, but whatever you get is just that single click or single button. As I said, it's just one button. I click on the button, activate, and then everything starts running behind the scenes. All these functions are running, but whatever you get is just like you don't really know what is powering all those functions behind the scenes. It's just that you get one function and all the rest are triggered behind the scenes. I hope we are at par up to that level now. Also, I'm not getting response. I don't know if I've been buffering. I don't know if I've been clear. I don't know if we've followed through, all of us. Guys, silence. I think these ones with the thumbs up are the ones the systems are running. They run the code, it's working. Can I get a response? Basically, be it positive, be it negative. We pick it and see whatever direction we have to take. Yes, I'm getting a good number now responding. How about the rest? Jonita has responded. Derek said, who else didn't respond? Conrad, you've been silent since morning. You joined in late. Is everything fine with you? Conrad? All right. Let's move on to the last bit of that, and that is now polymorphism. From the term poly. So poly basically means many. So many, so polymorphism is basically many forms. So child classes can change and override the method that they inherited from the parent. So they behave completely different from whatever the parent has. So that is what polymorphism is all about. So let's take, for instance, I'm creating a payment class, but I'm going to have different payment methods. So I want to have like the class is payment. Then I'll create a subclass of a payment that is, let's say, M-Pesa payment. Then I have card payment, such like. So if I want to achieve that, I'll just do polymorphism. So each and every payment method will have its own logic, basically as that. So it will just have its own logic. How do we pay with M-Pesa? So you have to key in the digits to that, say, send an STK push and trigger a payment. How do we pay with card? Validate the CVV and such like. So that is just the baseline on polymorphism. So polymorphism. So on polymorphism, let me just go to it as I've been saying. I create a payment. So this payment is going to take in a method. So we want to process a payment. So let's just call it process. So we want to process a payment, and let's just here just log that and say processing payment. So I'll just say processing payment. So this method, processing payment, is going to be inherited by every other class. But what is going to happen is now in this bracket, so in the code block area where you need to define how the payment is going to be done, it is now going to be implemented at the class, at the subclass level. So the process payment, let me just add a comment here so you see what I'm talking about. So payment implementation. So the payment implementation is going to be done at the subclass level. So the classes that are going to inherit from the payment class are going to implement the payment process themselves. So that is what is going to happen. So I'm going to create a class for M-Pesa payment. So I'll just say M-Pesa payment. So M-Pesa payment inherits from the payment class. So extends payment. And now here we are going to call the process method. And now this process method is going to now be implemented, as I said, at this level. So for now, let's just log and say console.log and say maybe sending STK push. STK push notification to the phone to trigger payment. So sending STK push to the phone, and then after that, maybe I can log another one here. So console.log and say payment should be in quotation marks. Payment successful. So you can have it that way. So the implementation is done at that given level and have another class. So all the classes that inherit from the parent are going to implement their own methods. So like you have one device, a remote control. Let me talk of a good example also of a remote control. So you have one smart remote control that when directed on a smart TV, it powers the smart TV on and off. If you direct it to your sound system, it powers it on and off. You direct it to your smart bulb, it powers the bulb on and off. So a single device, but the functionality is implemented according to what device is it being used on. So that is what we achieve with the polymorphism. So let me say card payment. Sorry, card payment extends payment. And here now, call the method. So call the method here and now pass in the console log again. So we can just do console.log. And this one, I can just pass in the message, whatever I was just explaining, validating CVV code with the bank. With the bank code. So we are validating the CVV, and then now we can log the last one and say maybe payment successful. Console.log payment successful. So after this, maybe let me create a function that now triggers payment so that you can select which maybe payment method you want to have. So let's have a function here. So let me call it function trigger payment, or let me call it checkout. So checkout. So my checkout function takes in a payment, let me call it payment object. So takes in a payment object, and being a payment object is basically either card or M-Pesa. So takes in any of those, and now take that payment object with the method that we have on the payment. So process. So pick whichever method it is and call the function on that given method. So just using that function, now we can trigger the method here. So I'll just call the function checkout my checkout function. So checkout, now this one will take in, now we can create the object in here. So new M-Pesa payment. So I'll just use the M-Pesa payment. So just call the method. So the object, I can call it directly on the function here, and now trigger a payment. And let's also call the card payment, so that you see what now we get here. So depending on which object it is, so if it is M-Pesa payment, so we are going to see sending STK push, then payment successful. If it is card, we see exactly that. So I have to run and see what we get. So now we can now see sending STK push notification to phone, payment successful. Validating CVV code with the bank, payment successful. So depending on what method, or on what object, sorry, on what object the method is being called. So remember the method, here you just create a method, and now you can see this one says processing payment. But when we run the function, we don't see, okay, I just highlighted that. Let me remove the highlighting. So when we run that, we don't see anywhere it's writing processing payment. So the function runs as what has been implemented at the class level. Make sense? Any question so far? Am I even audible? You guys, okay. Now, when you keep quiet and I've been having problems with network, I tend to think I'm yapping here and nobody's hearing me. All right, no questions to that point. I think the easiest of them is this polymorphism, which is not very, very difficult. The other three a bit complex. That's why I started off at that point, get to eat the hard stuff, then we come to, oh, this one is a bit light. Okay, so let me give you that quick one. I talked about a remote control. So I want you to create a class for the remote control, and now bring in the polymorphism. So extend it to different devices you want to power on. So that remote control on a TV. So what do you want to do with it on a TV? So on a fridge, what do you want to do it on a fridge? On they are smart powered, how do we call them? Microwaves, sound bars. So like implement it on at least four classes or 4 devices. So let me give you, this one should be a quick one, just 5 minutes max. Got it? Have we got that? I'm not getting response from you guys. You are so silent. All right. So just quick. Yeah, I've said I want you to implement polymorphism on a remote control class that is going to be extended to subclasses. That is a TV, can be a sound bar, can be even your light bulb, can be your fridge. So at least 4 devices in the house. So just that same remote powering on this, when directed on this given gadget, it does what it does on that gadget. When directed on this other one, the methods are device specific. Got it, Aisha? Aisha, is it clear? All right. I think it's about time. We checked what we have done. And yeah, Conrad, I've called you a number of times. I don't know if you can hear me. You joined and we've not heard your voice. You can share your screen. Let's see what you've done. Conrad?
Using to access the meeting. That's I'm on my phone only.
Yes?
My laptop is refusing to access the meeting. That's why I'm on my phone as only peke yake. I'm only on my phone.
Well, we have network issues. Okay. Right. Who will? Okay. Who will volunteer to share their screen and tell us what they've done before I select someone? If you all keep quiet. Any willing person? Janita, you can share your screen. Let's see what you've done. Hope you heard me. Okay. Yeah.
No, I haven't done anything.
Why?
I'm trying to wrap my head on what I'm supposed to be doing.
Any challenge? Let me start from that point. What is it you've not understood on that?
Is it going to be the same as what we did with the M-Pesa thingy? Yeah.
Yeah, basically, I just said you create a class for a remote control. And then now it's going to have, like, you implement the method of how the remote control is used on a specific device. If it is a TV, so what are you logging? So let's see that, like, if it is a method like power on a TV, so you tell us now, when I create a TV instance, I see the method working on the TV. If I point that device on a smart what? A smartwatch. Let me take, for instance, even a smartwatch. I point it on a smartwatch, it powers that on. So based on what device that gadget is used. So the method implementation is at the specific subclass level. That is basically what I was trying to bring across. I see how you're going to pick it up. Right, let me see it from someone else. Still on the ladies, let me strike out that and see what you have before I go to my gentlemen. Ida. And yeah, Ida, let me have it from you. And Abby, today you are also so silent. Ada?
Can you see my screen?
Yes.
Okay, I started by creating a class called device and using a method called press button, and the console log is button pressed on device. And then I create a class called TV and it extends to, I create a class called device. No, I create a class called TV and it extends from the device where the method is still press button from the device. And fridge, so the console log is fridge adjusting cooling temperature. For the TV is turning on. The same thing for the sound system class, which extends from the device, and and we use the press button method. And the console log is sound system posing music. The same for the light bulb, which extends from the device class, and we use the press button method. And the console log is changing bulb color. Then I create a function called remote control, and the parameter is device. Then we call the device press button, and when we come here and log this remote control, new device, TV, fridge, sound system, and light bulb, you can see what happens. TV is turning on, fridge is adjusting cooling temperature, sound system is using music and changing bulb color.
Right. Yeah, that's why I said this should have come in as a breather, a very easy one for us to do. Very good implementation from you. Congratulations on that. Let me see. Abby, I think I called out your name too. Let me see what you were able to do. Then I go to two guys, and then we move on to something else. Abigail?
Done yet. I'm still writing the code out. Yeah, I haven't done much.
Yeah, you just share what you've done. Like if your logical flow is on point, we just see, okay, you're on the right track. So it's all about, I said it's not about having everything done, but if you have got a grasp of what we are doing, then that is basically why I'm checking out on what you people are doing.
Okay. So you can all see my screen.
Yes.
So I just created a class, this one, called remote, and then the method process, and then the output console.log, what the remote is mostly used for. And then I created another class called TV, which extends from the class remote. And then the method press button, and then the TV is switching on. So I haven't done much. I'm still
and that's
continuing.
the reason why. That's the reason why I want you guys to share, so that we even correct whatever you are doing not correctly. To start it off, your line 258, creating classes. How did we say classes? Let me start off from that point. Right.
Yes.
Then let me take you back to the payment method we had up there. So go back to the payment method, scroll back up. I want you to compare and see. So from the class payment, we said we create a method that is going to be implemented in the subclasses. Are you getting it?
Yes.
And then it is the same method that is used in the subclasses, same method. So if it was to be press button, it was to be the same method all across. You now get it?
Yeah, I am.
Yeah, so like the relational information that I was giving is what I wanted to see you, okay, get. I create a class, give it a method, and I said this is a global method that is going to be used by all the subclasses that are going to inherit from this class, and then do the implementation at that class level. So what does the press button method do on a TV? That is what you will implement there. What does it do on another given device? That is how you do it at that given device, like that. I hope it's now clear.
Yes, it is.
Yeah.
Thank you.
Right. Let's get it from Derek. Derek, let me see what you've done. And lastly, I see it from who else? Derek,
Okay, let me
share your
share
screen. Okay.
Okay. Yeah. Okay, I'm also still working on it. I haven't gone so much on, yeah.
Like basically, you guys, you see, the reason why I'm even pointing out, let me hear it from so and so, like my intuition also just tells me, okay, basically so and so might not have done it. So I want to see basically why I'm bringing up these challenges in class for us to try out. I want to see our logical thinking. I want to see our thought process, even on the implementation of even these methods. Like we are sticking on, I can see you have stuck on the method process. Process was just a method I used on the payment. But for this remote class, which method can you apply on a remote control? What are the functions of a remote control? Is one of the functions process?
No.
Do you get that?
Yeah.
So, like, you bring in, okay, this is like the thought process should just be very clear. A remote control is used to power on devices. It's used to adjust volume. It's used to do, there are several methods I would have seen you even implement here. And having said this should have been the easiest, I expected like you are doing this really quick, connecting what we've done and just doing it really quickly. And even on your line 311, I'm seeing still you people are bringing in the problems, things I'm stressing out on. Still you start with them. And I even post, let me just say, like, when I get disappointed, I look back and ask myself, did I ask if someone is stuck or I just went ahead? I remember asking any question, all of you are silent. That is when I even went in and gave a challenge. Nobody raised the hand, said, okay, here I'm kind of stuck. Nobody. So if you get stuck and keep quiet, this doesn't go well. So we don't, like, you'll just remain behind as the others are moving. You are the one stuck and you didn't speak. So we assume all of us are at par, and then realize later on when a challenge comes, that is when we now show, oh, we haven't grasped this. So don't get stuck and keep quiet, please. Let's be communicating. Right. Let me take a last one before we go to something else. Let me give Japheth. Let me see what you've done.
Yeah, so I think it's here. So I created the first, oh, sorry, are you hearing me? Am I audible?
Yes. Yeah, you're audible.
Okay. So I created the first class, which is the parent class, the remote control. This here up, and then I went to line 2, in which inside the class I put in a default method, the turn on, and then I went to creating a soundbar, which is the subclass for the remote control. Yeah. And then what else? Yeah, that's the subclass. And then I went to the fridge, extended it still back to the same remote control. And then I created a function down here, which I'm trying to find the words. Which does what? Yeah, the function just goes back to the turn on here. Yeah, that's what I did. Is it okay?
Yeah, you run it for us. Let's see what it does, and yeah.
Turn on. Okay. Oh yeah. think I got an error here. Okay, seeing an error. Give me a minute.
What does it tell you?
This turn-on is not defined.
I think you've highlighted that word. Just remove the highlight from it. Yeah, and try run it again.
Oh, yeah, it's okay.
Yeah, when you highlight it, it kind of just removes it from the line, assumes you are still editing. It's not defined.
Okay, thank you.
Okay, fine. I think good implementation, good understanding up to that point. Anyone still stuck at this point? All of us okay now? Really taking time to just respond. I would have seen a quick response. Are we okay to this point? All right, so I'll assume all the rest are okay. And we can now basically interact with objects or object-oriented programming. So I know starting off from functional programming, things have been a bit complex, and yeah, we feel like it's been heavy, and that's why I've been a bit slow on these areas, so that we take in as much as possible. But not to worry. So things are easing out as we go. So yeah, let me give you 2 minutes, internalize what we've done. So just internalize that, then we go in and look at something else just in a bit. All right. I hope we are now internalizing. I know it will take time to understand more on that, but there's coming to be more of practice when we get to React. So not to worry, we still interact much more with the JavaScript in our next module. So there shouldn't be a lot of pressure on us. So I want us to go into looking at what we call, just check out where that is there. I want us to look at modules. Looking at my slides. Where they went. Let me check it out again. Let me just check them on my system. I had them somewhere here. Okay, I think got them. Yes, something's not what fine here. Let me see. Okay, so even without the slides, I can just take us through. I don't know what happened to these slides. They're not loading as I expected. But when we talk of now modules, close this first. When we talk about modules, basically this is a software engineering practice that breaks down large, complex code bases. Like now at this point, what we are doing is like I give you a project, you are going to create one big JavaScript file that has all the methods. Even if you have a multi-page application, you have all the methods, all the functions just in one code base. But now modularization is where we now break it down into smaller, independent, self-contained pieces. Like if you are doing payment, so you just have a payment module or functions just specific to payment. You don't want to mix payment with uploading images or updating profiles. So you don't want to have those mixed up. You just want to have simple or coupled or decoupled, not coupled. You want to have decoupled functions. You don't want to have one complete block. So decouple functions to their specific use case and just confine them in one specific area or one specific file. So that is basically like when you are building using Lego blocks. I've seen these games where you have a design and then you have you are given pieces that you want to just join in together until you have that a clear picture of whatever that design looks like. Those are what we call Legos. So using those Legos to, or Lego bricks to just piece things together. Like assembling a car, you are taken to a yard which has different parts of the vehicle scattered all over the place, or rather not basically scattered, but just put side by side. So this, there are no wheels, the frame, the chassis is that given point, the engine block is at that other side, and like that. You want to piece them together instead of manufacturing a car just a single block. You want to have pieces, like doing assembly. That is what we go for with modularization. So the key focus of this is just high cohesion. So the focus is on single module, as I've said, or single file. So every single file is just doing one extraordinary thing, or doing one thing extraordinarily very well, not mixing up any other task or any other thing. As I said, like for instance, when you are doing payment, should just be payment. And now in the payment, we have the payment methods and all that. So sending messages about payment, receiving payment messages, checking balances, all those are just inside the payment. That creates a single decoupled unit. So why do we modularize? We do modularize because we want to have easy maintainability or maintenance of our code base. So it is easy for you to find and correct a bug when you know like where exactly it is emanating from. So just seeing, okay, this bug is coming from this given area, and then you go to it and correct that. Don't know why the breaking is coming again. How am I right now? Am I now audible? Let me just have this file here so that we can read from here. So as I was talking of now maintainability, finding a bug can be very easy when you know exactly which file has or has thrown the error. You can just go to it and fix that. So code reusability, we always go with a dry aspect of do not repeat yourself. So if you have like a login function or a register function, that's basically like authentication, that's doing that work really well. You don't need to repeat that any other time you are coding. So you just copy and paste that entire file into or an entire folder into a different application, be it a different company you're working with. So code you are building even today can still be used 3-4 years to come, provided you've done something really perfectly. So you don't have to repeat that. That is why we go for modularization. Then collaboration with other teams. So when we go to the React, at the tail end, we'll do what we call collaboration. So working on the same project with other developers. So whatever developer A is doing, and whatever developer B is doing, they are not in any conflict. So this one can work on authentication. Another one is working on billing. Someone else is working on the product catalog that just lists all the products, such like. So different developers can work on the same project without having to touch each other's code, without having to overwrite what the other has done. So it makes it easy for you to work together. And then after this modularization, we're going to go into testing. That's why I brought in modularization. So it makes it easy for you to test modules, single modules. So we have what we call test-driven development, and in it we have unit testing. So you test a single unit instead of having to test the entire code base. So you test units, or you write automated tests that are going to just test single units and simulate the outputs of what you want for the application. So we go into it and start doing that and see what we are going to get. So how to do or the syntax of creating a module. So you create a single file that you are going to use in another place. So for instance, what I have here is a function that is going to calculate tax. It's a function that does calculation of tax. And so basically, I have not one, but just doing arithmetic. So I have a function that, like, the syntax is just you write the keyword export. So export, let me go back here. So let me come to it here. So the function, you have the keyword export. So export the function. So export and the function keyword. Then where you want to use it, you are going to import. So the next thing is going to be import. Import that given function where you want to use it, and then you are going to use it. So just let's go into it and see what it is and see what we get on this. Let me just close that, then go to it. So here, let's just create our file that is going to have the modules we are going to export and use. So let me create a file that does mathematics. So we just as what I've had there. So math utilities. So I'll just call maybe mathutils.js. So we create a file like that, and the functions, everything still remain as we have done. Things don't change here. So let's just create or declare a variable for the value added tax. So VAT, VAT rate. That was VAT rate is VAT is usually 0.16 is 16%, which is 0.16 of 100. So now, having said that, now you declare functions that are going to be exposed to the external world. They can be imported and used anywhere. So I do it with an export. So you do say export, then the name of the function. So export function, then give the name of that function. So we want to calculate what? Tax. So the function to calculate tax will take in the amount. This is a function we already done in a session before. So the function to calculate task is just going to return to us the amount. So we just get the amount. So we get back the amount, and the amount is going to be multiplied by our VAT rate. Then I can have another function. So you can create now functions in a single file. Just export the functions and then now have them imported and used wherever we want to use them. So let's create another one that does maybe just addition. So export function add nums. So add nums is going to take in parameters A and let's say B. So just takes two parameters and it's going to return the addition of those two given variables. So return A plus B. That is just a function to add numbers. So returns A and B. So in the script you want to use, so let's say you want to use it in a script called, do I have, I have script here. So let's just create a script. Let me call it main.js. So I want to use it in the main.js. So for me to use it, I'm going to use the keyword import. So you're going to import, and now in curly braces, you now return the functions that you have here. So I have calculate task and add nums. So I'm going to have them here. So I say calculate task, and you see it's even telling me the relative path. So calculate task, then comma, add nums. So it's already relating, saying, okay, there's a module that I need to import and use here. So then here I can do now like calculate the task from this point. So at this point, let's create a variable that is storing a product that has a price on it. So let's say product price. So the product price is, let's say this is 5,000 shillings for that given product. And then now we come in and now calculate the tax. So we want to get the tax due. So const tax due tax. Tax due is going to be equal to calculate tax. So you now call the function here and pass in this product price should have been even camel case. So pass in the product price here. That is going to calculate our tax. So if I log this and say console.log, the total tax due is, then we can pass in the tax due. is our tax due. That is the tax that we are to pay. We can even do the mathematics sum here. So let me declare a variable that is going to store maybe sum of numbers. So I'll just say sum equal to let me say equal to add nums, and now pass in the variables or the values. Let's say 25 and 40. So if we log sum, console.log sum, we should get the output here. So if we run this one, it should output for us what's that? Error module not found. Let's see, why is it module not found? Uncaught exception, cannot find module. Did you mean import? Yes, let me go back. There's something on see the error again first. Says did you mean main.js to import dot slash module not found. 1 minute, let's look at it. I picked up K. Okay, let me see. Let me create a a HTML for the same and see. Let's do module.html. Just want to have it run here and see what we get. So have modules. Let me just have a H1 and say welcome to modules. And pass in the script here. So the script here, now we pass in the type. So here you come in and say type and do module. So the type is going to be module, and then the source, that was main.js. Let me run this and see what I get in the console log. So we have this. So let's see the console output. Math utils not found. I think it's a path issue, so I wanted to confirm that. It was a module at our main.js. mathutils.js. Yeah, I was to add the .js at the last. I think that's why I was getting that error. So mathutils.js, I needed to have the entire path for me to output everything as expected. So you see now the functions are in this and they are used in this one, and now everything works correctly. I don't know if I've made sense of anything we've talked about as far as modules are concerned. Questions on the same? Okay, people are silent. Basically, this, as I said, we are doing things, some a bit complex stuff, but now very, very important that you get these ones because they are very key in laying out a foundation to whatever we are even going to do ahead. So tomorrow we are going to be talking about testing, and that's why I brought in modules and modularization of your functions or your scripts. And basically, when you'll be doing your projects, I know people are going to have even multiple scripts because someone has a page that is an about.html. There's a page that is services.html, another page, I don't know, product.html, and all those are going to be having functions. So related functions, the reason why I'm bringing in this is related functions can be bundled up together in a single file and just imported and used in the given HTML or given file So you import it as a module. So you import it as a module. And now when we open that file, we are able to see the modules that have been imported and used in that given file. So you can declare, or rather define, functions separately instead of having like 1,000 lines of code in a file and only consuming a few, the others are consumed in a different file. So you modularize the functions and you just import a module that you are going to use, making the code very, very easy to maintain, very, very easy to read through, and very easy to reference. Hope that is clear with us on that. So tomorrow we shall be talking about testing, and if possible, we also talk about, after testing, we talk about what else? Finish up with testing and go into jQuery. And that will be summing up almost everything we've done or learned in JavaScript, so that we set up, on Monday, we shall be setting up ourselves to start doing our project. Or basically, we can set it up tomorrow, start thinking of the projects we want to work on, so we can ideate that tomorrow after the lesson, and then now start working on it throughout the weekend, continue working on it on Monday, then we shall see when to present. I said because of the complexity of whatever we've been looking at, I've seen the inception of the last bits of JavaScript, which have been a bit overwhelming. So that makes it, next week, as I said, we shall be talking about what didn't come in well, how do we refactor what and what, until we have everything just packed together. So with that, I think we can call it a day, unless there's a follow-up question. If not, Matthew, you can give us your key takeaways in today's lesson, and then we wrap it up for today.